Hello and welcome to this video. This video is on solving questions on distance time and the speed time graph. The theory for these topics are already done. Now let us practice some questions. In this video we are going to practice 3 questions, and there are many more videos in which we'll be practicing more questions on these topics of distance time and the speed time graph. So let us start with our question number 1. Alright, a bus travels at a constant speed. It stops for short time and then travels at a higher constant speed. Using the axes that you see here, draw a distance time graph for this bus journey. So what they are saying, initially how is the bus traveling? Initially the bus is traveling at a constant speed. Then it stops for some time. Then travels at a higher constant speed. So the speed is constant. One is a smaller constant speed and next is a higher constant speed. In between it stops for a short period of time. So how do you plot a constant speed on a distance time graph? If you know the theory, you understand it is depicted as an inclined straight line. So let us draw inclined straight line. Right, this is part 1 of the question done. The bus travels at a constant speed. Next, what happens? It stops for a short while. How do you depict stopping on a distance time graph? Horizontal line. Part 2 of the question done. We have shown the stopping. Now the part 3 says, now it travels at a higher constant speed. Higher constant speed. How do you represent a higher constant speed? Again, an inclined straight line, but with a higher gradient. Higher gradient. Right? Constant speed depicted by inclined line, and higher is the constant speed, greater is the gradient. The steepness of the curve is higher. So part A is done. Let us come to part B. Our elevator lift starts from the rest at the ground floor of the building. So the lift is at the ground floor and it is starting from the rest. The speed time graph. Now this is your speed time graph. The earlier graph was your distance time graph. This is your speed time graph. For the motion of the lift to the top floor of the building is given to you. Use the graph to determine the distance from the ground floor to the top floor of the building. What is the distance from the ground floor to the top floor? So if you are given a speed time graph, how do you find the distance? The distance on the speed time graph is given by the area under the graph. So all that you have to do is you have to find the area under this graph, right? So how is the lift traveling? Let us understand. The lift is accelerating initially. The speed is going up. Then it moves at a constant speed. Then it is coming to a stop. Then the speed is going down. Initially, when it starts from the ground floor, the speed is going up. If you see here, the speed is going up. The speed is increasing from 0 to 1 to 2 to 3 point something. Then it moves at a constant speed for some time. Now here it is about to reach the top floor. It starts applying the brakes. The speeds are going down. Right? So to find the answer for B, which says to find the distance traveled by the lift or the distance from the ground floor to the top floor, we find the area under the graph. How do we find the area? Let us divide this graph into simpler figures for which we know the formula for finding the area. So here we have one triangle, another triangle. All you have to do, you have to find the area of this figure A plus the area of this figure B plus the area of this figure C. Let us find the area then. How much do you think is the area of A? It is a triangle. Half times the base of the triangle. The base of the triangle, how much is the base? Let us check it out. So it is 5 here, 6, 7, 7.2, 7.5. This point here looks like, if you see precisely closely, this is your 7.5 mark, and the mark here at the top, is look at the scale, you'll understand this is 3 point. This point is your 3.3, right? So half times the base of the triangle, this is the base of the triangle, 7.5 times the height of the triangle, this is your height, 3.3. This is the area of the triangle A plus the area of the figure B. The figure B is a rectangle, straightforward. The area of the rectangle is base times height. How much is the base? Let us calculate the base. Here it is 20. 20 minus 7.5. 20 minus 7.5 is how much? 12.5. 12.5 times how much is the height? 3.3. This is the area of B. Now the area of C. C is also a triangle, so half times the base. Base we clearly see here. It is 5. 5 times how much is the height? This line here gives you the height, and the height is 3.3. This is the area of the figure C, which is a triangle. When you do the calculation, you'll see the distance will come out to be 62 meters. Alright, so this question, I hope it makes sense. If you have any questions, any concerns, just type in the comment box and I'll try to answer each and every one of them. Let us now move to question number 2. So the graph shows the speed of a car. The graph shows how the speed of the car changes as the car passes through a small town. So you have a car, it is moving at a particular speed. It enters the town at point B. It decelerates. Maybe it was on a highway moving at a higher speed. It is entering the town, so it decelerates. Speed is going down. You see, speed is going down, deceleration. Then inside the town, it is moving at a constant speed. Again, it is a speed time graph, constant speed. Speed is lower because it is in a town, so higher traffic. Now it is entering the highway, it is leaving the town, again it is accelerating, and then after leaving the town, it again picks up a higher constant speed. Calculate the distance from the start of the town and the end of the town. You have to calculate the distance between the start of the town and the end of the town. So where is the start of the town? Here we are. Just hold on, let me take this slightly up. This is not visible. So start of the town is here. The end of the town is here. You have to find the distance. It is a speed time graph. How do you find the distance on a speed time graph? It is the area under the graph. The area under here is that of the area of a rectangle. Quite simple, right? So what is the magnitude of the width here? If you see, what is the magnitude of the width? This number here looks like it is 40, 42, 18, right? Now 42 minus 18, 24. This length is 24. And the height is how much? How much is the height? How do you figure out the height? The height is given here by this number. The height is height is 30. So you know the height, you know the width. So how much is the distance? 13 multiplied by 24. This gives you the distance of 314 meters. So this is the answer here. Right? Let us come to the B part. Calculate the acceleration of the car between the point C and D. You have to calculate the acceleration between the point C and between this point and this point. Acceleration. They are talking about acceleration, and this is a speed time graph. On a speed time graph, how do you find the acceleration? It is the gradient of the curve. Right? What kind of a line is it? What kind of a graph is it? It is a straight line graph. Right? So all you have to do is to find the gradient of this line. You have to find the gradient of CD. Gradient of CD is your acceleration. Right? So how do you find the gradient? You need to determine the endpoints. What are the endpoints? What are the coordinates of D? Let us find the coordinates of D. D looks like it is 54. D is 54 on the X, and how much on the Y? 31, right? So 31. Let's write the coordinates here. 54 and 31. What are the coordinates of point C? If you see, it is 42 and 30, right? 42 and 30. What is the formula for gradient? The change in height over the change in x, or you can say y2 minus y1 over x2 minus x1. So let us call this point x2, y2, this point be x1 and y1. Let us substitute the values. So here you have 31 minus 13 in the numerator, and in the denominator you have 54 minus 42. So this whole thing becomes 18 over 12, which is same as 1.5 meters per second square. You can solve this. 18.12 is 1.5 meters per second square. So B part done, A part done. Let us come to the part C. State how the graph shows that the deceleration of the car has the numerical value as its acceleration. How the graph shows that deceleration. There is a deceleration happening. Let us erase some of the extra bits of scribble from the graph. So where is the deceleration happening? Which part of the graph shows deceleration? Please try to identify. This is your deceleration. Why? Because the graph is going down. It is a negative slope line. Let us understand. Here if you see, the speed is going down. The speed of the car with every passing time, it is going down. Speed is decreasing. right? Speed decreasing means deceleration. So the part AB of the graph, part AB represents deceleration. So state how the graph shows that the deceleration of the car has the same numerical value as the acceleration. So the acceleration value you have already calculated 1.5. Let us calculate the value of the deceleration. Let us write the coordinates of the point A and B. What are the coordinates of point A? We had understood from our first point that A is A is not something that we have found before. So A is 10. 10 and 25. A is 10 and 25. What is B? It's coming out to be 18. 18, right? B is 18 and 13. 18 and 13. Let's call one of the points as x1, y1, the other point be x2 and y2. What is the formula for the gradient? We have to find the deceleration. Again, it means you have to find the gradient. Gradient is y2 minus y1 over x2 minus x1. y2 is 13. This is your y2, 13 minus y1, which is 25. x2 is 18 minus x1 is 10. So this whole thing becomes 12 over 8, or 4 3 times, 4 2 times, which is 1.5. Here if you see, the numerator is a negative number. 13 minus 25 is minus 12. Ultimately your answer will be minus 1.5 meters per second square, right? In the numerator, if you see, you are subtracting a bigger number from a smaller number. 13 minus 25 is minus 12, right? So the answer is a negative answer. Why is it a negative answer? Because the slope is, the line is going down, right? So negative 1.5, compare it with the earlier answer of positive, right? So here you had an acceleration, positive answer, same numerical value but with a negative answer. Because this was a positive answer, it was acceleration. Here you have a negative value, so it is a deceleration. Alright, great. So let us move on to the next question now. Question number 3. Question number 3 starts from here, this point onwards. So this is where the question starts. At a sports event, a champion runner and a car takes place in a race. The runner runs at a constant speed of 10 meters per second from the start of the race. The runner is running at a constant speed. During the first 5 seconds of the race, the car's speed increases from 0 to 25 meters per second at a uniform rate. Uniform rate means uniform acceleration. On the figure, draw a graph to show the motion of the runner. So let us complete the first part. Draw the motion of the runner. If you see here, runner is running at a constant speed of 10. So this is simple to do. It is a speed time graph. In a speed time graph, the constant speed is represented by a horizontal line. So this is your answer for part 1. Draw a graph to show the motion of the runner. It is a flat line. It is a speed time graph. It is a constant speed of 10, and if you see, this horizontal line represents 10 as the speed at all the points. No matter which point you're talking about, the speed value is 10. So this is the motion for your runner. Let us come to the part 2. Draw a graph to show the motion of the car. How is the car moving? During the first 5 seconds of the race, the car speed increases. The car speed is increasing from 0 to 25. 25 somewhere here. So on the other side, where do you think the 25 would be? Here, right? So this is your graph for the car. This is your graph for the car. The car is accelerating from 0 speed, and ultimately it reaches a speed of 25. And if you see here, between 30 and 20, between 20 and 30, you have 25 here. This is your 25 marks. So car started with a speed of 0, reached a speed of 25. 25 in the 5th second. 5th second, the speed was 25. The coordinates of the last point is time 5, speed 25. At the starting point, time 0, which is origin, speed is 0. Compare the information with the information which is given. In the first 5 seconds, the car speed increased from 0, y coordinate 0, it's increasing to 25 in 5 seconds. Alright, it is a uniform rate. Why? Because it is a straight line which is inclined. So therefore, in a speed time graph, we know a straight line which is inclined represents constant acceleration. Right? Now let us come to the part B. Use the graph to determine the distance traveled by the runner in the 5 seconds. Where is the runner? This is the graph for the runner. In a speed time graph, how do you find the distance? It is the area under the graph. So which area are they talking about? This area. Right? So what is the distance traveled by the runner? It is the area, which is a rectangle. So base times the height, 10 times 5, 50. This is your 10 and this is your 5. So distance traveled is 50. Let us come to the second part. The distance traveled by the car in 5 seconds. Which area are they talking about now? Which area? Now they are talking about this area. They are talking about this area. How much is the distance traveled by the car? It is the area under this curve, which is a triangle. It is a triangle, so we use the formula for the area of the triangle. What is the formula for the area of the triangle? It is half base into height. Half base into height. So half times, how much is the base? If you see, the base is the same. 0 to 5. So base is 5 multiplied by the height. So how much is the height? The height of the triangle is this, which is 25. Right? So this whole thing becomes 125 by 2. You divide it, so 6, 2 6 are 2, 2 2s are 4.5 meters. So these are your answers. Alright. So the time at which the car overtakes the runner, the last part. We have to talk about the time when the car overtakes the runner. So what would that time be? That time will be the time when the distance traveled by the car, becomes equal to the distance traveled by the runner. It happens when the distance traveled by the car becomes equal to the distance traveled by the runner. That particular moment of time when it happens is the time when the car overtakes the runner. Now let us come to the picture and try to find some symmetry here. If you look at the time value of 4 and draw a line all the way up. Right? Let me erase a few stuff here. I'm erasing all this marking so that you understand it well. Alright, now let us have a look. The area under this curve for the graph now looks like it is equal to the area for the runner. Compare the two areas. Let us say that this area is A, this is B. We are talking about this area between the triangle. And if you see the symmetry, this is also B. They both are equal. B and B, there is a symmetry, they both are equal. Right? So this is more of geometry. How much is the distance traveled by the runner from 0 to 4? From 0 to 4. So let us talk about from 0 to 4. How much is the distance traveled by the runner? The distance traveled by the runner is area of A plus the area of B. We are talking about this area plus this area. This is the area of this rectangle. A, B plus A. How much is the distance traveled by the car? This is the area under this curve, which is also A plus B. And this thing happens when the time is 4 seconds. So 4 seconds should be your answer. 4 seconds is a value of the time where some kind of a symmetry here is created at the area of this triangle here. This small triangle becomes equal to the area which is formed on this side. Right? So the time value answer for part 3 is 4 seconds. So this is the last question on this video. For more questions on speed time and the distance time graph, please check out the next other set of videos as well. Thank you so much.